Hi everyone, welcome to Couchbase Coding with Matthew Groves. This is a 10-minute slice of my day as a developer advocate, live on Twitch every day at Matthew D. Groves. Check out old episodes on YouTube, send me questions and comments on Twitter or email. So welcome to week 2. I made it this far, so that's a good sign, I think. I hope you're enjoying it. I have a mission statement with 5 bullet points, so I thought I'd go over, since there's 5 days in a week, go over those one a day just to give you an idea of what this stream is about. So basically telling you why am I live streaming like this, and basically the short answer is my goal is to be a better developer advocate. So the first point of that is basically the job description is to reach as many developers as I can, engage with them through this stream or through other means or other mediums. Get some feedback on Couchbase, on the documentation, on what you can and cannot do with Couchbase, and not just Couchbase, but other cool stuff that I like that is generally going to be related to Couchbase. So that's the reason number 1. Be 4 more reasons this week. And also, before we get on with the coding, there's some business. Friday's episode, I had to go back and edit it. Unfortunately, I accidentally showed some personal information in that stream. Not a big deal, but the edited version is available on YouTube, and I had to remove it completely from Twitch. So if you're looking for episode 004 on Twitch, it's not there, but it is on YouTube. All right. Today, I'm going to finish up some of the code samples that I've been working on for that blog post that I keep talking about that's going to be published soon, but it keeps getting pushed back a little bit. That's okay. I have some time to talk about durability. So the post I'm writing is basically about all the different parts of ACID that make up an ACID-compliant ACID properties of a database. And what I've been talking about with the optimistic and pessimistic locking focuses on the I in ACID, the isolation. But I also want to talk about now the D, which is durability in ACID. So what I've got here is a C# example, just the same code base as before, but I've got everything commented out except for the durability example. So the durability example here, and a lot of this is actually happening not so much in the C#, but it's happening at the Couchbase level. So Couchbase architecture is what's called memory first. So when you put some data or a mutation into Couchbase, that change gets saved into memory first. So it's very, very fast, right? If you have to wait on the disk, it's going to be slower. So the idea is here you put the data in memory, and then it gets put into a queue to be saved later asynchronously, hopefully quickly, but later, to disk, one, and also to be put into a queue to be stored on other nodes in the cluster. So Couchbase is a distributed database, which means it's not just one machine, typically, it's multiple machines acting together as a cluster. And one of the things that distributed databases give you is that if one machine goes down, the rest of the cluster can provide continuity, can keep running, so that if you have a problem with one machine or a problem with one part of your network, you can still serve your web application with data. And replication is an important part of that. All right, so here's the default behavior here with Couchbase. This is the memory first behavior. I'm going to use that bucket object. I'm going to upsert a new document, or upsert a document with the key of memory first. And it has some data here. It doesn't really matter what this data is for this demonstration, but I've got my Twitter handle in there, mgroves. And so once that upsert runs, the SDK is going to send that data off to Couchbase. It's going to put it in memory, or could fail potentially, right, out of memory, or something other crazy happens, the connection string is not there, or whatever. It's going to return success or fail. We're going to probably expect success here locally, so this is going to be true. I'm going to write out success. So now, at this point, the document is in memory, and it's being put into a queue to be written to disk and or replicated, sorry, I'm going to mute my phone, and or replicated to another node later. But now you might be saying to yourself, well, if it's only in memory at this point, what happens if the machine loses power? Then my data is lost, right? It's memory only. It's a little more volatile than being saved to disk or being saved to some other machine. Well, that's a good point. And so that is a risk that you kind of are taking there. You're putting data into memory. But the trade-off is you're gaining speed. Now, fortunately, Couchbase gives us some options to mitigate that risk. And now it's still memory first. It's always going to be memory first, right? And so the disk written is going to be asynchronous. But we can specify here at the upsert level, we can say, okay, there's another document I'm creating with this key, with a different value as my email address at Couchbase. If you want to contact me, feel free. But I'm saying, okay, now in this case, I want you to make sure that this document is replicated to one other node. And if you look here, I can also specify 2, 3, or 0 other nodes. So that's at this individual document level when I'm doing this upsert operation. Now, if I go back over here to Couchbase, let's bring this up. I'll just maximize this. If I go to my buckets, and I'm editing my bucket settings, now if I hit advanced bucket here, I can enable replication at the Couchbase level itself, right? So I can enable 1, 2, or 3 other backup copies of this data, all right? So that's what's happening at the Couchbase level. So what I'm doing at this level here, at the SDK level, is I'm saying, let's check to make sure that's happening. And if that doesn't happen, we'll consider this unsuccessful. So let's just put a not up here, because I expect this to not be successful. All right, now it doesn't mean that it won't get replicated eventually. It just means that if this fails, at the time I inserted this document, the replication did not happen. So that's going to fail for sure. It's going to fail for sure this time because I only have one node running on my local machine. So it's going to fail for sure. But if I add more nodes later, that replication will happen. All right. So it's a little bit, maybe a little confusing at first because you've got two different places where we're doing replicating here. I've got a comment here from Dead Inside Help. No, wait. What is Couchbase coding? Looks like a winky face. Look at the previous videos for the answer there. tinyurl.com/cbcoding for YouTube videos. I assume with the winky face you're joking. All right, so then that's replication. Then the next level, I can also specify persistence. And I can say, well, this needs to be replicated to one node and persisted to one node. And persisted means saved to disk. So this is also probably going to fail, again, because of replication here. But it's going to probably, the persist part is going to succeed. But I could say persist to 1, 2, 3, or 4. Right? Because I could have up to 3 replica copies and 1 master copy. So 4 would be the maximum here. So this is going to say, all right, I want to check to make sure this document actually gets saved to disk, gets persisted to disk. And if it doesn't, this is going to return a false. Now, that doesn't mean the document will not be stored in Couchbase. It very well could end up still in memory, right? But not yet persisted to disk. I'm not sure what situation would occur where it's not persisted to disk, but it's saved in memory, maybe out of disk space or something crazy like that, right? But this gives you a more concrete success or fail message. So if this fails, you can say, well, I can't be sure that it's saved to disk, so then I can do some other logic here. I could do a retry, I could try saving it somewhere else, I could send an email, I guess I could write a log message, I could do all of the above there, because now I have some more information about, did this actually succeed or not? Well, do I know that it succeeded or not? It could still end up succeeding and getting written to disk, but at this point I might have to assume that it didn't actually succeed. So it just gives you some more control over that, if that is more important to you. Now again, the trade-off here is this is going to take more time to actually make sure it gets to disk. I don't know, the SDK I think might be doing some polling behind the scenes, but it's going to take some additional time. So that's the trade-off here, is that you get more of a guarantee that it's persisted, but it takes more time to do your operation. All right, so let's set a debug point and step on through this and see what happens. So I'll bring Couchbase over here, and I'm just going to look at the bucket, documents in the bucket. So right now I just have the 3 documents from the last examples, the shield, weapon, and magic. And we're at the 10-minute mark, so let's get started on this here. Okay, so right now I've got a console that's not showing anything. But let's just step through this. So memory first, and you can see that it was successful. And if I go over here and do a quick refresh, instead of waiting, you can see that, yes, memory first actually did end up here in the database. And I'll scroll over and you can see there's my Twitter account right there. All right. So this should print out success to the console, and it does. Okay. The next one, I want to insert a different document, replicate to one, and I want it to replicate it to one other node. Now this should fail. It should return a false here, I should say, and that is the case. However, if I refresh my Couchbase console, notice that replicate to one is here. All right. So it was saved to Couchbase and was eventually saved to disk, but it was not replicated to another node. So that is the part that makes this say it was not successful. All right. Now, if I went ahead and added another node to Couchbase here, this would replicate it to it automatically. But at this time, that replication failed because there's no place to replicate it to. Okay, and that might even have an error message here. Yeah, not enough replicas configured on the bucket. Okay, fair enough. So this is also going to fail, and that's what's written out to the console. Okay, we'll do it one step further here, and it's now replicate to one and persist to one. So I'll do that again, and this is with a key of replicate to one, persist to one, obviously. This is also going to be false, but if I refresh this again here, you can see that it did make it into the bucket, which I fully expected, but it was not replicated, right? So if I look at the error message, again, not enough replicas configured on the bucket. If I set this to replicate to 0 and persist to 1, it would probably be success equals true, okay? So write that message out there. There you go. So it succeeded. The first time, it did save the document. The next two times, it just failed in persisting them, or failed in, obviously, it failed, the checks to see if it persisted failed. All right, so that's it for durability. Look for the blog post. It'll go into some detail on this as well, and it's also spelled out in the documentation. But I want to say thanks for watching, and we'll see you tomorrow.